Space is vast, it's filled with stars, planets, and galaxies. But what we see is just a tiny fraction of what's out there. The universe holds hidden secrets, mysteries that have puzzled scientists for decades. Two of these enigmas are dark matter and antimatter. They sound like something out of science fiction, but they are very real. Dark matter is like a cosmic ghost. We can't see it, but we know it's there because of its gravitational pull on the things we can see. Imagine a bowling ball hidden under a blanket making the blanket sag. That's dark matter, its gravity tugging on galaxies. Antimatter, on the other hand, is like matter's evil twin. For every particle of matter, there's an antiparticle with the opposite charge. When matter and antimatter meet, they annihilate each other in a burst of pure energy. These two cosmic mysteries are essential to understanding the universe we live in. They challenge our understanding of physics and push the boundaries of our knowledge. Join us as we delve into the fascinating world of dark matter and antimatter. The Big Bang. The universe explodes into existence. It's a maelstrom of energy, a cosmic soup of particles forming and annihilating at unimaginable speeds. But something strange happens. For every billion particles of matter, 1,000,000,001 particles of antimatter appear. It's a tiny imbalance, but it's crucial. Most of the matter and antimatter annihilate each other, their energy fueling the expanding universe. But that tiny excess of matter? That's what survives. That's what makes up the stars, the planets, and even us. Antimatter might seem like something out of science fiction, but we create it every day in particle accelerators. These powerful machines smash atoms together at incredible speeds, producing tiny amounts of antimatter. It doesn't last long though, it quickly meets its matter counterpart and vanishes in a burst of energy. The mystery of the matter-antimatter imbalance is one of the biggest unsolved problems in physics. Why is there something rather than nothing? Why is there more matter than antimatter? It's a question that continues to fascinate and puzzle scientists. Galaxies are vast collections of stars, gas, and dust held together by gravity. But here's the problem, there's not enough visible matter to create the gravity needed to keep them from flying apart. They should be ripping themselves apart, but they're not. Why? The answer, scientists believe, is dark matter. It's a mysterious substance that doesn't interact with light or other matter in the same way that ordinary matter does. It's invisible to our telescopes, but we can infer its presence by the way it affects the movement of galaxies. Imagine a giant cosmic spider web, its threads woven from dark matter. Galaxies are strung along these threads, their movements dictated by the invisible web's gravitational pull. Dark matter is the scaffolding upon which the universe is built. We still don't know what dark matter is made of, but we know it's out there. It's 5 times more abundant than the matter we can see, a hidden majority shaping the cosmos with its unseen hand. Shaping the universe, the unseen architects. The universe we see today is not a random scattering of stars and galaxies. It's a structured and organized place, with vast cosmic filaments of galaxies separated by giant voids. But how did this structure arise from the chaos of the Big Bang? The answer once again lies in the unseen realms of dark matter. In the early universe, tiny fluctuations in the density of dark matter created gravitational wells that pulled in ordinary matter. These clumps of matter grew larger and larger over time, eventually forming the stars and galaxies we see today. Antimatter, while less directly involved in this process, played a crucial role in the universe's first moments. Its annihilation with matter provided the energy that fueled the Big Bang's expansion, setting the stage for the formation of stars, galaxies, and ultimately, life itself. Peering into the darkness, the quest for understanding. Scientists are constantly searching for answers about dark matter and antimatter. We're building bigger and better telescopes to study the movements of galaxies, hoping to learn more about the distribution of dark matter. We're also creating increasingly powerful particle accelerators, trying to create and study antimatter in the lab. The quest to understand dark matter and antimatter is a journey into the unknown. It's a challenge that pushes the boundaries of our knowledge and forces us to rethink our place in the cosmos. What we discover could revolutionize our understanding of physics and reveal the universe to be even more strange and wonderful than we ever imagined.